Today we're going to talk about Cauchy-Euler's differential equation. This equation is in form a0 times x to the power n over dny upon dxn plus a1 x to the power n minus 1 over dn to the power minus 1 y over dx n minus 1 to a to the power n minus 1 x dy over dx plus a to the power n y is equal to some coefficient 5 over x, where a0, a1 and a to the power n minus 1 are real constants. This equation can be reduced to a linear differential equation with the constant coefficients only by transformation. We have to transform this equation to change into Cauchy-Euler differential equation. For transforming this equation, we have to let x is equal to e to the power t. If there is another variable, suppose if in place of x is u or other variable, we have to assume u. Okay, we can also assume u is equal to x to the power lambda. Some other coefficient can be. We have to suppose u is equal to x to the power lambda. But this is one question. X squared to the power x squared into t square y over dx square minus 2x over dy over dx plus 2y is equal to x cube. There are constants with 2x and 2y, and there is no constant with x square. In another example, x square u double dash plus 3x u dash plus 5 u over 4 is equal to 0. In this equation also there are constants with u dash and u, and there is no constant with x u double dash. This is we can recognize that this equation can be transformed into Cauchy-Euler differential equation. All we have to do is assume u is, in this equation there is u, so we have to assume u is equal to x to the power lambda. Then we have to take its derivative for finding u dash, and after that we have to take a double derivative for finding u double dash. After taking its derivative, u dash is equal to lambda to the power x, lambda x to the power lambda minus 1, and u double dash is equal to lambda in bracket lambda minus 1 x to the power lambda minus 2. After taking derivative, we got this value. After taking double derivative, we got this value. Now putting this value in this equation. After putting this value in the equation, we got the equation lambda bracket lambda minus 1 bracket close plus 3 lambda plus 5 over 4 bracket close overall x to the power lambda is equal to 0. Now all you have to do is to change this equation into quadratic equation for finding roots, which we have to put in Cauchy-Euler's equation. We have to change this equation in the quadratic equation. After simplification, we got lambda square by multiplying, and overall we get lambda square plus 2 lambda plus 5 over 4 bracket close x to the power lambda is equal to 0. Now this is quadratic equation. Now all we have to do is finding roots. By finding roots, you all have done, you all of us know how to find roots of quadratic equation. By finding roots, we get lambda is equal to minus 1 plus minus 1 upon 2i, and I squared is equal to minus 1, and alpha, find roots of alpha is equal to minus 1, beta is equal to 1 over 2. These roots are complex. Now this is Cauchy-Euler's equation. All we do is put these values of lambda, alpha and beta in equation of Euler. The equation is u is equal to x to the power minus 1 bracket ln bracket alpha ln x. In the equation it is alpha. Again, the equation is like u is equal to x to the power minus 1 a ln bracket alpha ln x plus b sine beta ln x beta ln x bracket close. This is the equation. All you have to do is put the values of alpha and beta in this equation. By putting these values, u is equal to x to the power inverse. By putting values, in place of alpha there is 1 upon 2, and in place of beta there is 1 over 2. In place of alpha there is minus 1. Sorry, minus 1. By putting values in alpha there is minus 1 and beta is 1 over 2. And these are a and b are constants.